Hello everyone, welcome back. In previous lecture, I explained about the geometric tolerances. Let us recall about it. So, about the geometric tolerances and the terms used in geometric tolerances: datum feature, triangle, letter, and datum system. And the advantages of using geometric tolerances: indication of feature control. These were the indications. Now, and I also explained briefly about the limit gauges now and why limit gauges are necessary. Now, in today's lecture, we will further move on to the basic concept of gauge design, the Taylor's principle. Now, according to Taylor, go and no go gauges should be designed to check the maximum and minimum material limits. The term minimum material condition and the maximum metal condition are used to describe the tolerance state of workpiece. The go gauge is made near to maximum metal condition, यानी कि जो गो गेज हम डिज़ाइन करेंगे वो मैक्सिमम मेटल कंडीशन के लिए होगा, मतलब जो होल का है वो मतलब मिनिमम साइज है उसको कंसिडर करके, मतलब वो जो है वो मिनिमम, मतलब गो गेज उसमें जाना चाहिए और नो गो गेज है वो उसमें से नहीं जाना चाहिए। यानी कि गो गेज मस्ट बी एबल टू स्लीप इनसाइड और ओवर फीचर विदाउट ऑब्स्ट्रक्शन। फॉर एग्जांपल, plug gauge for checking hole size as shown in figure, having exactly go limit. As you can see, go plug gauge as inside hole. What will happen? It will be able to slide inside the hole without any obstruction. So the plug gauge is very good example for explaining this Taylor's principle. So go gauge is basically designed for the maximum metal condition. Similarly, opposite is no go gauge that is designed for the minimum material condition or minimum material limit, which means it does not pass through hole for the part to be accepted. If the go gauge passes from the hole, that means the hole is acceptable. And if the no go gauge does not passes through the hole, that means it is acceptable. Otherwise, in the opposite cases, it will be rejected. Now, the diameter and the length equal to engagement length of fit to be made for checking go limit of workpiece, and this gauge must perfectly assemble with the workpiece to be inspected. जो डायमीटर और लेंथ है वो इक्वल होनी चाहिए to the engagement length of the feet to be made checking go limit of the workpiece, and this gauge must perfectly assemble with the workpiece to be inspected. Similarly, the no-go gauge is made near to minimum metal condition. Now, no-go gauge which contacts the workpiece surface only in two diametrically opposite points, and at these points it should have exactly no-go diameter. No-go gauge must be able to slip inside or over the workpiece in any consecutive position in various diametric direction of the workpiece length. यानी कि जो नो गो गेज है वो स्लिप और स्लाइड नहीं होना चाहिए जो भी हमारा वर्कपीस है या फिर कोई भी डायमेट्रिकल पार्ट है उसके अंदर. So this is about the basic concept of gauge design, about the no go gauge and go gauge. Now there are various types of limit gauges. Let us discuss them one by one. So The first classification is based on the according to their purpose, which means the workshop gauges. Workshop gauges are the working gauges are those used to batch or machine in gauging the work as it being made. Then second thing is inspection gauges. These gauges are used by the inspection personnel to inspect manufactured parts when finished. Third one is the reference or master gauges. These are used only for checking the size or condition of the other gauges. These are the first type of classification according to purpose, whether they are supposed to use in the workshop for the inspection purpose or whether they are going to be used as a reference or master gauge. Second number classification is according to form of tested surface. According to form of tested surface, in which the first is the plug gauge. Plug gauge are basically used to check the dimensions of a hole, while the ring gauges, very importantly, they are used for the checking the dimensions of the shaft. Then after ring gauges, the snap gauges are used. They are also check the dimensions of the shaft, but the snap gauges can be used for both cylindrical as well as non-cylindrical work as compared to that ring gauges which are conveniently used only for the cylindrical work. So non-cylindrical means it may be oval shape. Okay, according to their design, it will be single limit or double limit gauges. Single-ended, double-ended, both side gauges are mounted. Then fixed and adjustable gauges. So these are the classification. Now the first type is the plug gauges. Plug gauges are used for checking the holes and consist of two cylindrical wear resistant plugs. The plug made to lower limit of hole is known as go, and this will enter any hole which is not smaller than the lower limit allowed. What it tries to say? It says कि जब भी कोई प्लग गेज है हम यूज करेंगे फॉर चेकिंग होल या फिर कोई दो सिलेंड्रिकल कंसिस्ट ऑफ टू सिलेंड्रिकल वियर रेजिस्टेंस प्लग्स, यानी कि कोई जो भी होल हमको चेक करना है उसके लिए दो वियर सिलेंड्रिकल वियर रेजिस्टेंस प्लग होंगे और वो प्लग क्या चेक करेंगे? लोअर लिमिट चेक करेंगे होल की। अगर गो गेज है मतलब वो उसमें सेटिस्फैक्टरीली एंटर करना चाहिए, अगर वो नहीं एंटर करेगा तो that will part will be not acceptable. And on the other hand, if the hole is smaller than that lower limit, so which means the go gauge will not be able to insert or slide inside. Now the plug made to upper limit of hole is known as the no go gauge, and this will not enter any hole which is smaller than the upper limit allowed, which means we have fixed the upper limit, and if the part is smaller than that upper limit, which means the no gauge will be able to, if it will be able to slide inside that, that means the part is not acceptable, which means the upper limit is fixed and the plugs are arranged on the either end of a common handle. One end we can fix a go gauge and on the other hand we can have a no go gauge we can use in the combination. The ends are hardened and accurately finished by grinding process. The end part of the go and no go gauge are hardened and grinded. Then the one end is the go end and other end is the no go end. If the size of the hole is within the limit, the go end should go inside the hole and no go gauge end should not go. If the go end does not go, the hole is undersized, and also if the no go end goes, the hole is oversized. If go is does not going inside, which means the hole is undersized, and if the not go gauge goes inside the hole, which means it is the oversize. Hence, components are rejected in the both the cases. So this is all about the plug gauges. Now, the you can see in the figure the go end and no go end are arranged on the both end of the plug as shown in figure, and this type have the advantage of is easy manhandling and are called double-ended plug gauges. So these are also called as the double-ended plug gauges. This one is the go plug gauge and this one is the no go plug gauge. These are the cylindrical plugs. Now, in case of progressive type of plug gauges, as shown in the figure, both go and no go end are arranged in the same side of the plug. We can use the plug gauges ends progressively on one after the other while checking the hole. It saves time. Generally, go end is made larger than the no go end in plug gauges. Go end is made longer than the no go end in the plug gauges, but this one is the for the progressive side when it is the provided at the same side. We can use it progressively one after the another while for checking the hole, and it saves time, which means the go gauge should go inside and not go gauge should not go inside. Now in the plug gauges there is the taper plug gauges. As shown in the figure, the taper plug gauge are used to check the tapered hole. It has two check lines. One is go line and another is no go line. During checking of work, no go line remain outside the hole and go line remain inside the hole. There are various type of taper plug gauges and are available as the taper plug gauge. They are the plain taper plug gauge, tanged taper ring gauge, then plain and taper ring gauge tanged. So this one is taper plug gauge. We can see over here. This one is the ring mark limit of go plug. Second one here mark is for the no go line. The another type is the ring gauges. Here you can see just simply this one is before that the plug gauge in the taper plug gauge. If this line does not appear, it should not appear when inserted in the component. So the part will be acceptable, and if and this line should appear because it is no go line. You can see these are the various types in which the plain type taper plug in taper plug it is the tanged taper ring gauge, the plain and taper ring gauge that are also tanged. Then another type is the ring gauges. Ring gauges are similar to that. Ring gauges are used for checking the diameter of shaft. They are used in similar manner to that of go and no go gauge. A ring gauge consists of a piece of metal in hole required sizes bored as shown in figure. The hole is bored accurately and finished by the grinding and lapping after taking the hardening process. The hole of the go ring gauge is made to the upper limit of the size of shaft and no go for the lower limit of the shaft. The periphery of the ring is knurled to give more grip for hand which the handling of the gauges is done. Normally the go ring goes and no go ring are separated using jack shaft. Okay, so here there is one no go ring and over here is there is one go ring. Generally no go made with a red mark or small groove cut on its periphery in order to identify the no-go gauge. It is cut with a periphery or this red line marked over here. So up to this we will keep today's lecture. Thank you very much for listening carefully. Have a nice day.